And I don't know if we have time for questions or.
Thank you. Hey, thank you very much, Clay.
Sure.
I thought that was a very exciting presentation. Mario's down there in the middle. Anybody like to shoot a question at Clay while we're here, hot on this topic? Or you're all stunned? Huh? Come on. Yes. If you could state your name and company affiliation, we'd appreciate it.
I'm Stu Keller with ExxonMobil. Just on the human-robot collaboration, I recently saw a demonstration where a doctor performed heart surgery from the U.S. on a patient in the U.K.
Yeah.
Isn't that already sort of in progress as human-robot collaboration?
Well, interestingly, medical robotics are exempt from the existing safety standards. I mean, does this make sense, right? So, they have to go through rigorous clinical testing, right? Probably much greater than is involved with industrial systems. So they kind of have a separate path for ensuring safety. So there is, in fact, prostate surgery is widely done with robotic surgical systems today. The Da Vinci system is now heavily used for robotic surgery. And that's safe, it's effective. In fact, it's much better if any of you have to have this in your future, ask for the robotic solution. It is safe. In short, the industrial solutions are governed by different safety standards. So in some ways, the medical industry has gotten out ahead.
Tom. Corporation. The Connect technology, do you see that again as a new disruptive technology being used in the element of safety? Being able to look at an environment, assisting people, being able to shut equipment down?
Yeah, absolutely. In fact, NIST has a working group currently, which is addressing that very problem. So one of the ways which you ensure safety in these sort of human-robot collaboration activities is by having a highly reliable and in many cases redundant sensing solution. And so what does that look like? Well, the regulations are evolving currently. And as I mentioned, NIST has the National Institute of Science and Standards and Technologies has a working group right now which is trying to address that, trying to provide guidelines on how do you ensure safety and reliability, especially for these human-robot collaboration situations. So it's already being done, not with the Kinect, but with simpler sensors. So there are like laser scanning solutions from organizations or companies like SICK and others that are able to reliably detect the presence of humans in robotic workspaces. But right now, those are used mostly for excluding humans from that work environment. So they just detect if a human comes into the environment and then they stop the robot. What you'd really like to do is be able to determine what the human is trying to do and whether or not they're doing it safely in the context of that robot interaction. And those are the kinds of problems which are still sort of research opportunities.
Jagbir Dinsa, Axon Drilling Products. More to related, this maybe is closer to the oil and gas. We've done a project where you do have the safety issue. They wanted the welder within the cell to view the welding process.
Yeah.
We're a Motorman distributor, so they came up with a solution. They have a independent driver that lets that meets those standards, and so that's more of that's going on right now, and that's in Houston, and related oil field equipment using robotics for a manufacturing process.
Yeah, and it is happening right now in certain circumstances. There's a class of applications though where humans are literally interfacing with robots, like sharing tools or both working on the same work piece. And those are very difficult to get around today with the current safety regulations, and rightfully so.
Walter from Schlumberger. Are you aware of what work is going on in system verification for the software? I mean, not human robot interaction is one thing, but just verification for autonomous systems. And how do you approach that?
Yeah, so it's a very important topic, right? It's a little outside of my domain, and I may not have the full answer for you. But on the industrial systems, now they do allow for software in the loop on some of these safety systems. So that's how they are allowing this kind of human-robot interaction. And there are guidelines which are set up through these standards on how you test and validate those software solutions. I don't know all the details there. And one of the things that's really complex is it's more than just a product-driven problem, right? So you might have a sensor and a robot, and both of them are verified safe. But when you put them together, you have to verify that that system is safe, because they might be integrated in poor ways that are unsafe. And those are some of the issues that are trying to be addressed with these new standards, is how at a system level safety is maintained.